In this video, let's go ahead and practice calculating density, mass, and volume together. Now, essentially, we're going to have three different variables. We're going to have this lowercase d for density, a lowercase m for mass, and a capital V for volume. When you're trying to calculate the density of something, you're just going to go ahead and take the mass and divide it by the volume. Now, what if you're trying to find the mass? You're just going to take the density of that object and then multiply it by its volume. And then finally, if you want to find the volume of an object, you just go ahead and take its mass and you divide it by its density. In terms of units, we have a few different types of units we want to be aware of. Now, generally speaking, when we're talking about density, we're going to be talking about grams per centimeters cubed. You can also think about this as kilograms per meters cubed if you're talking about heavier or larger objects. Then for mass, we're typically going to be measuring these in grams or kilograms. And then for volume, we're going to be measuring in cubic centimeters or cubic meters. Now, in some particular problems, you may see that you see volume measured in milliliters. So just keep in mind that 1 cubic centimeter is equivalent or the same thing as 1 milliliter. To consolidate all the formulas into a small table here, to go ahead and find density, just go ahead and take the mass and divide by the volume. To find the mass, go ahead and take the density, multiply by the volume. And to find volume, just go ahead and take the mass and divide by the density. For a quick visual, I think these triangles are helpful to kind of imagine what these formulas look like. Notice how for all three of these triangles, the mass is going to be at the top, the density is going to be on the bottom left, and the volume is going to be on the bottom right. If you can set up this triangle each time, the formula is a little bit easier to remember. Alright, so notice how density is on the bottom left here. To find density, you just take this mass and divide by the volume. So you can actually see that the mass is on top and the volume is on bottom, so you know it's division. Now what about to find the mass? Well, the mass is on top here, and mass is just going to be density multiplied by volume. So notice how they're both next to each other on the bottom of the triangle. So you can see that we're going to multiply them as they're next to each other. Finally, to find volume, notice how that's on the bottom right here, and we're just going to take the mass and divide by the density, which kind of makes sense because you see the mass is on top and the density is below it, kind of how it looks like in a fraction for division. Alright, now that we hopefully know the formulas a little bit better and we understand the units that we're going to use, let's go ahead and try some examples together. For these first two examples, let's just go ahead and start by solving for density. So for number one, we're going to be solving for the density of a block of silver. We know how much it weighs and we know how much space that it takes up. We're told that it weighs 62 and 94 hundredths grams, so that must be the mass here. Let's go ahead and write that down as 62 and 94 hundredths grams. And when we're told that it takes up 6 cubic centimeters of space, that tells us the volume of this block of silver. So we're going to go ahead and say that's going to be 6 cubic centimeters. Alright, so what's our formula again? And so going ahead and making some substitutions, we know the mass here is going to be 62 and 94 hundredths grams. Let's go ahead and take that mass and dividing it by the volume here, we know the volume is going to be 6 of these cubic centimeters. So we'll go ahead and put that on the bottom as 6 centimeters cubed. All right, so to go ahead and calculate this density, let's just go ahead and complete this division problem. So off on the side here, let's go ahead and take this 62 and 94 hundredths, and let's divide that by 6. 6 goes into 6 one time. 1 times 6 is 6. We're going to be left with a remainder of 0. We can bring this 2 down. Now, how many times will 6 fit into 2? Well, it's going to fit in 0 whole times, so we're going to put a 0 here. 0 times 6 is going to be 0, and we're going to subtract, and we're going to be off by 2. Now, don't forget to bring this decimal straight up into our quotient, so it's going to be 10 point something. And let's go ahead and bring this 9 all the way down. Now, 6 into 29 goes in 4 times. 4 times 6 is 24. We're going to be left with a remainder here of 5. Finally, if we bring down this 4, this is 54, and so 6 into 54 is going to be 9 times. 9 times 6 is exactly 54, so this works out really nice. So we have a quotient here of 10 and 49 hundredths, and this is basically telling us the density of this block of silver. So we're going to say this is going to be 10 and 49 hundredths. Now, in terms of units, what do we have here? Well, we have grams from on top, and we have cubic centimeters on bottom. So we're just going to keep those units here. It's going to be grams per cubic centimeter. And so we can say that our density for this block of silver is going to be 10 and 49 hundredths grams per centimeter cubed. Make sure we always have those correct units for density. All right, let's try another example together, except this time in number 2, we're going to be talking about a block of gold. All right, so we know we're going to be looking for density, so we're going to leave this blank for a moment. We're told how much it weighs, which means that's going to be the mass of this block of gold. So that's going to be 150.54 or 150 and 54 hundredths grams. And we're told how much space it takes up, which is another way of saying volume. So the volume here is going to be 7 800 cubic centimeters. All right, so we're going to use the same formula that we used in number 1, where density is equal to mass divided by volume. And we actually know the mass and the volume. So let's go ahead and practice this one more time. So substituting in, we can write our mass of 150 and 54 hundredths grams in the numerator. And let's go ahead and divide that by our volume. Our volume is going to be 7 8/10 cubic centimeters. All right, so don't worry about the units right now. Let's just go ahead and take care of the division problem. So we really have this 150 and 54 hundredths. And we're going to go ahead and divide that by this 7 8/10. Now, I wrote it like this just so we can be very clear. We want to make sure that our divisor is a whole number. So we can make this divisor a whole number by multiplying it by 10. But if we multiply that one by 10, we're going to also multiply our dividend by 10 as well. So this way we can divide by 78, which is a little bit easier than dividing by 7 8/10. So rewriting this, we're going to have 100, instead of 150.54, we're going to say 1505. So 1,505 and 4/10 divided by 78. All right, so the answer to this division problem right over here would be the same as the answer to this division problem over here, or their quotients would be the same. So let's go ahead and set this up. I'm going to put this 1,505 and 4/10. Let's go ahead and divide that by 78. All right, so 78 won't go into 1 a whole number of times, or 15, but it will go into 150. I think it's going to go in once, because if you do twice, that's going to be, I think, over 150. So this is going to be 1 times 78 is 78. We're going to see we're going to be off by how much? Well, 10 minus 8 is going to be 2, and then this would be 14 minus 7 is going to be 7. Okay, so if you need to write out the borrowing, go ahead. This 5 is going to come on down to make this 725. Now I'm going to have to do some scratch work on the side here. I know 78 times 10 is 780, so that's too much. So I'm going to try 78 times 9. Let's see here. That would be 72. Carry the 7. 63 plus 7 is going to be 70, so 702. I think that's as close as we can get. So I'm going to put a 9 up here. Don't forget to put that decimal. So we have 702. Let's see, we're off by, looks like 23. And finally, let's go ahead and bring down this 4 here. So we have 2, 3, 4 at the end. Let's go with 3 here maybe. Let's try 78 times 3. Let's see, that's going to be 24. Carry the 2. 7 times 3 is 21, plus 2 is 23. So it's exactly 234. So we're going to put a 3 up here in our quotient as well. And that's exactly 234. So our remainder here is 0. So what is our quotient? Our quotient is 19 3/10. So we can go and say our density here is going to be 19 3/10. What kind of units do we have? Well, density, we divided this grams by cubic centimeter, so don't overthink it. Let's just put grams here divided by, or per, cubic centimeters. And so this right here would be the density of this block of gold. All right, for these next couple problems, let's switch it up a little bit. In these ones, let's go ahead and see if we can calculate the mass instead. So for these problems, we're going to go ahead and look for the mass. So let's use a different version of that formula. Now we're told what the density is. The density we already know is going to be 8 96 hundredths grams per cubic meter, right? So hopefully those units make sense from earlier. And then we're told the volume, which is going to be 5 cubic centimeters. Again, we always have to know 2 out of the 3 variables here. So in this case, we know density and we know volume. All right, so the version of the formula that we want to use for these particular problems to find mass is going to be mass is equal to density multiplied by volume. And so substituting in here, let's write our density, which is going to be 8 96 hundredths grams, and that's going to be per centimeters cubed, right? So I'm going to write per, and I'm actually going to go ahead and write it as 1 centimeter cubed, just because that's what that is representing, okay? And we're going to go ahead and multiply this by our volume. Now our volume here is going to be 5 cubic centimeters, so I'm going to write it as 5 cubic centimeters. And I'm going to write that over 1, just because you can write this as a fraction, anything over 1. All right, so when you go ahead and multiply fractions, we're just going to go ahead and multiply the numerators here and then multiply the denominators over here. So let's go ahead and do those calculations on the side. I'm going to take this 8 and 96 hundredths and multiply that by 5. This shouldn't be too bad. 6 times 5 is going to be 30, carry the 3. 9 times 5 is 45, plus the 3 is 48, carry the 4. Then 5 times 8 is going to be 40, plus 4 is going to be 44. And we need 2 decimal place values here. So moving over twice, this is going to be 44 and 80 hundredths. You can also consider this to be just 44 and 8 tenths. That's fine as well. So when you go ahead and multiply these on top, what are the units and what are the values going to be? Well, the mass here is going to be 44. Let's go ahead and write this out as 44 and 8 tenths. But what are units? Well, we have these grams multiplied by centimeters cubed. So we can go ahead and write that as grams multiplied by centimeters cubed. And what's going to be underneath here are in the denominator. So on the bottom here, we have 1 multiplied by 1 centimeters cubed. So 1 times 1 is just going to be 1. And we're still going to have the centimeters cubed down here. All right, notice that we have the same units on the top and bottom. Anything over itself cancels out to make 1. And we also can say here that we could simplify this and say this is going to be 44 and 8 tenths. And we're just going to write grams here, just because if you divide by 1, you can simplify that and just say it's going to be whatever the numerator is. So the mass in this particular problem for this block of copper is going to be 44 and 8 tenths, and it's just going to be measured in grams, which makes sense because mass is generally going to be measured in grams. All right, let's go ahead and try another example that's very similar. So hopefully this one feels a little bit better now that we tried one. So let's go ahead and find the mass again. So when looking for the mass, we must know the density and the volume. So we can see we're given the density here of 1 and 738 thousandths. And this is going to be grams per cubic centimeter. Hopefully those units make sense. And we're told it takes up 35 cubic centimeters of space, so that's going to be volume. So we're going to go ahead and write that as 35 cubic centimeters. So then go ahead and just identify what our formula is going to be, where mass is density multiplied by volume, and those are the 2 variables that we do know. So let's go ahead and make some substitutions. So for the density, how are we going to write that? Well, we're going to go ahead and say it's going to be 1 and 738 thousandths, and this is grams per 1 centimeter cubed. So it's going to be grams on top, and it's going to be 1 centimeter cubed on bottom, right? So whenever you're doing it per cubic centimeters, it's per one of those. And then we're going to go ahead and multiply this by the volume. Now the volume here we know is 35 cubic centimeters. So let's go ahead and multiply 35 cubic centimeters. And this one isn't a fraction, but you can write all whole numbers as fractions by putting it over 1. All right, so we're just multiplying fractions here. Let's go ahead and multiply the numerators together, and then we'll multiply the denominators together. One of those is definitely a lot easier than the other though. All right, so on top here, let's go ahead and take this 1 and 738 thousandths. Let's go ahead and multiply that by 35. 8 times 5 is going to be 40. Let's put a 0, carry the 4. 5 times 3 is 15, plus the 4 is going to be 19, carry the 1. 5 times 7 is going to be 35, plus 1 is 36, carry the 3. And then 5 times 1 is 5, plus a 3 is going to be 8. Let's put a placeholder here, and then let's get rid of this 5, 4, 1, and 3. And now let's use the 3 here. So 3 multiplied by 8 is going to be 24. Let's carry the 2. 3 times 3 is 9, plus 2 is going to be 11. We'll carry the 1. 3 times 7 is 21, plus 1 is 22. Carry the 2. And then 3 times 1 is 3 plus 2, and that's going to be 5. So here are our partial products. We can go ahead and add these together. We're going to get 0. Let's go ahead and put that's 13, carry the 1. That's going to be an 8. That's going to be a 0, carry the 1, and that's going to be a 6. I think we need 3 decimal place values here. So we're going to put the decimal right over here and make it 60 and 830 thousandths. But you can also say this is going to be 60 and 83 hundredths. Those would be equivalent. All right, so multiplying the numerators here together, let's go ahead and write this out. The mass here we can say is going to be 60 and 83 hundredths. But what happens when you multiply grams and cubic centimeters together? We can just write G for grams multiplied by cubic centimeters, or cm cubed here. And that's going to be our numerator. But what about the denominator? Well, we have 1 times 1 on bottom, which is just going to be 1. And then we have cubic centimeters on the bottom, so we can just keep those units the same and just write cubic centimeters. All right, so I'm writing these cubic centimeters in that same color just so we can see that we can cross those out because anything over itself is equal to 1. And then we can just go ahead and simplify this a bit more and just say that this would be 60 and 83 hundredths, and this would just be grams, which makes sense because we're looking for mass. So we can go ahead and just say that our mass here would be 60 and 83 hundredths grams. All right, so we did 2 practice problems where we solved for density. Then we just did 2 practice problems just now where we solved for mass. Let's go ahead and do 2 more here, but this time let's solve for volume. All right, so we're gonna be solving for volume. That means we must know what the density and the mass are going to be. All right, so you can see here that we know the density is gonna be 21 and 45 hundredths. This is grams per cubic centimeter, so just go ahead and write that in. And we're told how much it weighs, so we know the mass is gonna be 128 and 7/10 grams. All right, so what's our volume formula? That's right, it's gonna be mass divided by density. So again, they're all the same formula, just written in different forms here. Let's go ahead and make some substitutions though so we can solve for the volume. All right, so substituting in here, our mass is gonna be 128 and 7/10 grams. Let's go ahead and just substitute that in the numerator here. And dividing by the density, we know the density here is gonna be 21 and 45 hundredths, but this is gonna be grams per centimeter cubed. All right, so to figure out this volume here, let's go ahead and just take this 128 and 7/10 and divide it by this 21 and 45 hundredths. So I'm gonna go ahead and write out the original division problem over here like this, 128 and 7/10. We're gonna go ahead and divide this by 21 and 45 hundredths. Now, when we divide, we like our divisor to be a whole number, so dividing things into piles of 21 and 45 hundredths is a little bit tricky to think about, but if we go ahead and make this 100 times bigger, multiply this by 100, and go ahead and multiply this one by 100 as well. If you make these both 100 times bigger, we can solve this a lot easier or understand it a lot easier. So if we do this, this would be 1, 2, 8, 7. You have to add a 0 here, so it's 12,870. We're going to divide this by 2145. So I think it maybe makes more sense to divide things into this many piles as opposed to this many piles. But the answer to this problem will be the same as the answer to the original, right? So let's go ahead and take this 12,870 and let's go ahead and divide this by this 2,145. So 2,000 isn't going to fit into 1 a whole number of times, or 12, or 128, or for that matter, 1,287. So let's go ahead and see if we can just try figuring out what number this goes in evenly, or at least as close as possible, right? So let's see, 2,000 into 12,000. I feel like we could go with something like 6. Let's go ahead and give that a try. If we try something like 6, that's going to be 30, carry the 3. That's going to be 24 plus 3 is 27, carry the 2. That's going to be 6 plus 2 is going to be 8, and then that's going to be 12. Well, that's exactly 12,870, so this actually wasn't as bad as it might have seemed like in the beginning. So this is exactly 12870. You can see here that the remainder was 0 here. All right, so we just found out when you went ahead and divided these two values, we found out the bottom actually goes exactly into the top 6 times. So we can go ahead and say here that our volume here is going to be equal to 6. Now we would go ahead and just write that as 6 of these grams per 1 of these grams per what? It's gonna be grams per cubic centimeter. So you can write it just like this. I'm just gonna write the cubic centimeters in this green color just because that is the units we're gonna use for our volume. And now if you're trying to wonder how the units do make sense here, keep in mind that this is a division sign. So you could also write this as 6 grams over 1. And if you go ahead and divide this by this denominator of 1 gram per cubic centimeter, it's gonna look like this. That's gonna be 1 of these grams per 1 of these cubic centimeters. Now, what do you do when you divide fractions? Well, you can rewrite all division problems as a multiplication problem. We could take our first value of 6 grams as 6 grams over 1. Let's go ahead and multiply by the reciprocal of that second fraction. That's going to be 1 cubic centimeter. If we go ahead and flip this upside down, that's going to be over 1 gram. So we can put 1 gram on the denominator instead here. Now, if you multiply, you can see on top here that if you multiply 6 times 1, that's just going to be 6. So it's going to be 6 grams per cubic centimeter, or multiplied by cubic centimeters. And what about in the denominator? Well, on the bottom, 1 times 1 gram is just going to be 1 gram, so it's going to look something just like this. Now you can see here that these grams are going to cross cancel with each other. Again, anything over itself is just going to be 1. So we can say here that this is just going to be 6 cubic centimeters. Hopefully that makes sense because we were looking for our units to be in cubic centimeters for volume anyway. So this we can say is going to be 6 cubic centimeters. That's the volume of this block of platinum. All right, let's try one more practice problem. We're going to find volume one more time. All right, so we're going to look for the volume, and we're told that the density here is going to be 19 3/10 grams per cubic centimeter. And we also know that the mass is going to be 328 1/10 of a gram. Our formula here is going to be volume is equal to mass divided by density. So let's go ahead and take our mass here. Let's write that in as 328 1/10 of a gram. Let's go ahead and divide that by our density here. Our density is going to be this 19 3/10 grams per centimeter cubed. All right, so in reality, all we're going to do here is just take these two decimals and divide them. Then we'll have our volume. Hopefully you know what the units are going to look like, but let's go ahead and give this a try. So let's go ahead and take this 328 1/10. Let's go ahead and divide that. See how many times this 19 3/10 is going to fit inside of it. Again, we don't like dividing by decimals if we can help it, so let's divide by whole number. So we can multiply both of these decimals by 10 to go ahead and have that same effect here. So if we go ahead and do this, the division problem that's going to be easier for us to do is going to be 3,281 divided by this 193. All right. So our dividend is going to be 3,281 or 3,281. Let's go ahead and divide that by our divisor of 193. Now 193 doesn't fit into 3 or 32 a whole number of times, but it will fit into 328. I think if you double 193, that's already going to be over 350. It's going to be close to 400. So I'm just going to go say 1 time. So let's go ahead and do 1 times 193. That's just 193. And let's make sure our remainder here is going to be under 193. So we're going to have a 5 here, and then 12 minus 9 is going to be 3, and then 2 minus 1 is going to be 1. So this 135 is less than 193, so that makes sense. Let's bring down this 1. Now, let's see, 193 is close to 200, and 1351 is close to 1400. Maybe I'll try something like 7. Let's do 193 multiplied by 7. Let's see, that's going to be 21, carry the 2. That's going to be 63 plus 2 is 65, carry the 6. It's to be 7 plus 6 is going to be 13. This is exactly 1351. So we like this. Let's put a 7 up here. It's going to be exactly 1351. Got a remainder here of 0. So how many times will this 19.3 fit into 328.1? Fits in exactly 17 times here. All right, so let's go ahead and see how we're going to go ahead and write this. Well, we calculated this to be 17, so this is going to be 17 what? It's 17. We have this grams in our units here, so it's going to be grams per, and 17 as a fraction is really just 17 over 1, right? And then for our units here, we have grams per, and I'm going to change the color of the units for centimeters cubed to what we're looking for in volume. So hopefully you remember what happened last time we did an example in number 5. But let's go ahead and rewrite this so you can see why the units end up being centimeters cubed. So if it didn't make sense earlier, hopefully it'll make a little more sense this time. So remember, this fraction bar, or all fraction bars, can be thought of as division. So we can write the 17 grams as 17 grams over 1, right? That's exactly what that is. But we're going to go ahead and think about this fraction bar as division. So let's go ahead and write that division sign. And this is going to be 1 gram over 1 cubic centimeter, right? So we can write this as 1 gram, put 1g, over a cubic centimeter. Well, a cubic centimeter is really just 1 cubic centimeter. So let's go ahead and write it as 1 and then cubic centimeter. All right, so how do dividing fractions work again? Well, let's go ahead and rewrite this. It would be the same thing as taking our first fraction and multiplying by the reciprocal of the second fraction. So 17 grams over 1 multiplied by, let's go ahead and flip this one upside down or write the reciprocal. That's going to be 1 cubic centimeter. And that's going to be over 1 gram. So I'm going to write it as 1 gram just like this. All right, so if you go ahead and just simplify this a little bit here, 17 times 1, that's just going to be 17, as we knew the answer would be. And then for our units here, we have grams multiplied by centimeters cubed. Just put a dot in between to keep it organized. And that's going to be over what? It's going to be over 1 times 1 gram. And that's just going to be 1 gram. Now remember, anything over itself is just equal to 1. So gram over gram just cancels out here. So you can see we're just left with 17 over 1, which is really just 17. And this is going to be cubic centimeters. So that's going to be the volume of this block of tungsten here. So let's go ahead and write that's going to be 17 cubic centimeters. Now, if all the work with the units kind of was a little confusing, as long as you memorize what the units should be for density, mass, and volume, that will work as well. Just make sure you know when to multiply your values versus divide your values. And then if you memorize your units, you can just go with that as well. So that wraps up 6 different examples where we practiced finding density as well as mass and then finally volume. If you found the video helpful, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.